Hi, I'm Brian from Simply Brian Enterprises, and welcome to my channel. Today's video, we're going to be looking at homework solution for TopTechBoy's Raspberry Pi class, lesson number 15. In this lesson, we're going to be doing an analog read with the Pi. Now, if you're familiar with Raspberry Pi, you'll know that it does not natively have support for analog read, and so we're going to accomplish this using an analog to digital converter. As is the usual, we're going to take a look at the hardware, run the program, and then take a look at the code. The first thing I want to look at is the breadboard itself. I've got my cat talk button here for exiting the program. And then I have my AD converter, my ADC0834 that's included in the Sunfounder kit. You'll notice that I have some custom jumpers to save space. I think it was Wild Bill who was mentioning the use of these multicolored 22 gauge wires. I purchased these on Amazon a while ago, 25 feet, and I am in no danger of using these up. Although if that day ever comes, I will be ordering the 20 gauge as opposed to the 22 gauge. I think they fit a little better in the board, but certainly nothing wrong with the 22 gauge, especially when I have 25 feet of each color. You may notice that I'm not using the T expander that's included in the Sunfounder kit. And the reason is because of the amount of real estate that the expander takes up. I want to use that real estate for my components and not give it all to the expander. I can get away with this because in my design of the redabbler, I have the Raspberry Pi in close proximity to the board. In fact, it's on risers, it's above it. So I can very easily use these short 10 centimeter male to female jumpers. So here is my GPIO pin for the cat talk button. Here's the 3 pins for the ADC converter, and then I have my single output for my red LED. The potentiometer is also installed, but that doesn't go back to the Pi because there's nothing to read from the potentiometer in the Pi. I have it wired negative and positive, and then the wiper actually goes into the ADC. I do want to make a point in wiring up this particular potentiometer, and I'm going to use a larger one so you can see what I'm talking about. When we install a potentiometer on the breadboard, we typically want to have left all the way down. And you can see that that is the case here. If you can see the arrows pointing down to the left. When we do that, it's negative to the left, positive to the right. That gives us an output of all the way to the left, 0 volts, all the way to the right, 5 volts. And you'll notice also I've got my 5 volt rail, I've got my 3.3 volt rail. Don't fry the Pi. We want to make sure we know which voltage is which. The ADC converter runs off of 5 volts, but the cat talk button is using the pull up on the 3.3. Very important. Don't fry the Pi. Now we're going to head into the program, but before we run the program, we need to talk about the fact that we need a third-party library in order for the Pi to use the ADC0834. And the library is easily located on TopTechBoy.com. It's right on the front page. You can just copy paste into a text file. But the question is, where do you put the file? If you're running a stock install of Debian Buster on your Raspberry Pi, it's user lib Python 3.7. I am not running Buster, I'm running Bullseye. And on top of that, I have a custom compiled Python version 3.99, and I'm using a virtual environment. So where does the library go so that when I type import ADC0834, it's going to load the library? Well, there's a little technique we can use to do that. So I'm in my virtual environment, and I'm going to type Python to launch my interpreter. Remember, Python in my virtual environment, everything points to 3.99, so I don't have to worry about specifying Python or Python 3 or Python 3.9. They all go to the same place. And I'm going to import sys. And I'm going to print sys.path. And this variable, this built-in variable in Python, shows me where we're going to look. I'm going to get rid of that. Where we're going to look to find our libraries. And as you can see, we've got a master zip file. We've got user local lib Python 3.9 because I have everything installed in user local bin Python 3.9. We have libdynload, dynamic load, I guess, and then we have a library directory within the virtual environment. So in this case, I want to install it in a place where it's going to be accessible to all my virtual environments. So I'm going to choose user local lib python 3.9. And actually, if we go in and we import OS, we can actually see, I hope I typed this right. There we go. There's all the files in that directory. It's the same as doing an ls, but it's in Python, so it's fancier. And here we can see as I list that libpython 3.9 directory, here's my adc0834.py. And so I can comfortably just come in here and bring in adc0834, and it loads correctly. So I just wanted to show you that because it took me a little bit of figuring out, because I have a custom path to my Python, where exactly new libraries are going to go. I think in future lessons this is going to be a value that we want to keep tabs on where our libraries are actually stored. And so I'm going to go ahead and run my program. And I made the decision to continue using VPython. I'm still not very good at VPython, but I figure if I keep including it in my programs, I'm going to have to learn. So right now I have my potentiometer all the way to the left. And as I start to turn my potentiometer to the right, we see the light on the board getting brighter, the VPython ball getting brighter, 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 all the way to maximum brightness, back down to half brightness, down to quarter brightness, back to half brightness, and we see it's following exactly what I'm doing with the potentiometer, all the way down. And then, of course, if we want to cleanly exit the program, we've got to have some cat talk. Strike 3 and you're meowed. Now, one thing I do not know how to do is cleanly exit VPython without getting errors. Usually I get an error here when I exit the VPython. I suspect there's a way to gracefully close your VPython session, but I don't know how to do that. So if you have some advice in that, leave the comment below. I'd love to hear your VPython success stories because I'm still very, very new to it. All right, and finally, we're going to take a look at the code. And I'm going to get rid of that so we have a little more room to see. And so I'm bringing in VPython, RPi, GPIO as Pi pins. Here I'm bringing in ADC0834. Again, because it's in that directory, it's going to load without error. And we're going to switch to BCM numbering because that's what the ADC0834 library uses. Here's our cat talk pin. Here's our LED pin. LED is out. Cat talk is in. This is nothing new. LED frequency is set to 100, clearing the cat talk counter. And then I'm going to start my PWM, and I'm going to start it with a value of 0. So that way it's obviously not outputting anything to the LED. One step I missed the very first time I ran this program is I forgot to include this line, ADC0834.setup. Without this line, you don't actually load the library. You can load it up here, but it doesn't do anything until we run the setup script. And without that, we don't actually get to use the AD converter. So unlike, well, my programs this far, I have kind of the same structure. I go through this never-ending loop. Every time through the loop, I write out the state of the LED or the state of the VPython or both. And it's further down in the code that I have an action where I press a button and change something. This one's a little different because the ADC converter is constantly sending data. So even if I'm not changing this potentiometer, it's always sending that binary data back to the Pi. And so I don't have to do a special section to actually read it in. I can just read it in every time. So the very first thing I'm going to do is I'm going to ask the ADC0834, what is the value of channel 0? Then before I do any conversion, I'm going to write that out to my VPython because this is going to be a value of 0 to 255. This is a value of not 255, but a value between 0 and 1. So I'm going to do a float of the value divided by 255 to get that fraction between 0 and 1. Obviously 0 is going to be 0, 255 is going to be 1, and everything in between just kind of works out. Then I'm actually going to start converting. So I'm taking my potentiometer value of 255, or of 0 to 255, and changing the range from 0 to 100. And I'm doing this the same way I've done this before. Basically just take the value and divide it by 2.55. I like leaving the actual divisors in here, 255 and 100, so you can see how this range becomes this range. This is the top of range 1, this is the top of range 2, basically. Then we come down and we need to convert our linear potentiometer value into an exponential because our output pins are exponential. So here again, we raise 10 to the power of that value divided by 100, so we get the fraction, and then we multiply it by 10 to get, because that'll give us a number between 1 and 10. Then we want to expand it out to be basically 10 to 100, I guess. And we know that if the value is 10, that's actually 10 to the 0, so we want to set the PWM value back to 0. We've done all that before, but I just wanted to do a quick refresher. And then lastly, we actually write out the new duty cycle in the exponential value. So that way, when the potentiometer is at 50%, then we know that our PWM value is whatever that exponential value of 50% is. And then we have our usual cat talk button code in here. We're just going to grab the state of the cat talk pin, increment the counter. If we hit 3 strikes, we're meowed. And then we set the duty cycle to 0, PWM stop, pi pins cleanup. And the reason I want to do all 3 steps is because once in a while, if I don't do that, the next time I start the code, it somehow picks up what it was the time before if I don't stop the PWM. So I always want to make sure I clean up. And again, I really have a question for those who are good with VPython. I want to be able to gracefully shut down my VPython image with the cat talk button, so I don't have to do the extra step of closing it out. And it didn't this time, but a lot of times it gives me errors when I do that. So really looking for some advice there. I hope you enjoyed this video. I know it got a little long, but I had a few things I wanted to talk about. If you like this video, be sure to hit like and subscribe below. Leave a comment, let me know what you're thinking, and I look forward to hearing from you and seeing you next time. From Simply Brian Enterprises, thank you for watching.